Assalamu alaikum. This is Faisal Ahmed on behalf of my group and my other group mate Janta Mondal will do the simulation part, and you can see him at the right side of the corner of the screen. So now this is the paper we are going to recreate. It is from the IEEE journal site. This paper was published at 2019 and this is available on every well-known site. There you can see and download the paper. Detailed survey and information of this paper was also done by other group mate Mahadi Mahi and Malavika Mukherjee. The paper which we will reproduce is named as Single Feed Circularly Polarized Microstrip Antenna with bath holes and radiation patch. So now let's go to CST software. Now you are seeing that this is our paper, we just reproduced it. Reproduction has done, the fabrication was taken from the original paper and the reference is given at the paper. And this is the graph and the far field point and every details we have given in our in our reproduction paper. Everything is given in this paper that we have reproduced. So first let's go to the CST software. So now we are going to create a new project. Then we select the MWRE optical option. Then we will use antenna because we will be designing antenna. Then we have to select the patch slot option because we are going to work on a patch antenna. We can choose any other option also. If you want to design any other antenna, then we will choose the time domain because we are designing a wide band antenna. Now these are the unit parameters of the antenna. This unit can be changed, but we will not going to change, and we will select the next option. So now we are giving the minimum frequency 1.20 gigahertz and the maximum frequency to 2.10 gigahertz, and it is given as exactly from the paper we are going to reproduce. Then we are going to select the E field, H field and far field monitors because we are going to observe the monitor after simulation. This antenna designing, you can also select the other option to show other result. Now at define at this value we can be changed, but we're not going to change these values for the simulation purpose. Then we'll select next and click on the finish. So here is our radiation box. Now we are going to see the radiation box we will use to design a 3D version of the antenna. This will be look like a graph paper. So the vertical middle point is y-axis and the horizontal middle point is the x-axis. We will use this axis to design our antenna. So we are going to design antenna, and the white color now we are going to see are the subtract, and the holes are the base holes we are going to design. The dimension of the antenna is the square shape, and the pink color is a patch of the antenna. The parameter box is taken from the journal paper. All the values we are going to use it is from the journal paper. So let's go again to our CST. This value so fast. So now we are giving all the parameters and the values like length of the patch, length of the patch antenna, length of the antenna, wide of the patch, and then LS, then the radius of the patch. So now our parameter input is done, and we have given the input as exactly is given in the paper as a reference because we are reproducing it. Now we are seeing that we are giving the same input in the parameter box. Then we will go to the CST software again. Still saying that every values are giving in the input as the parameter unit. Then we are giving the last values of the parameter unit to the box parameter list. These are the box, this is the radiation box, and we will do all our designing on this box. Now then we will select modeling, and then we will select break, and we will skip it, and a box will pop up. This box will be used to design planes. Name is given in the ground plane because we will design a G plane, and the x minimum is L minus LGND by 2, and the x maximum will be LGND by 2, y minimum is LGND by 2, and y max is positive minus LGND by 2. We will give all this value to here uh, for maintaining a balance as like as the reference paper. Then we then we will give the value of y minimum, which is positive LGND by 2, LG by 2, and the y maximum is as LG by 2, positive LG by 2. Then we are going to give the Z mean Z as 0 and Z maximum as TG. We are putting the values of Z maximum, and we're going to use the TZ. Then TZ and is the thinking of the ground pin. Then the material is PC, then select preview. It's okay. Then we are going to select the material as copper. Yes, we're going to select as material as the copper. Now it looks okay. Then we will select as preview. Now it seems okay. Now we're going to select okay. Now we will work for the subtract part. For designing the subtract, we click on the break and then select the skip button again, and box will pop up. For designing the subtract, we will give the name as subtract, and the x minimum will be minus LGND by LG by 2, and x maximum will be positive LG by 2, and the y minimum will be LG by 2, and y maximum will be LG by 2, and the Z minimum we are going to take, so Z minimum will be Z minimum will be TG, and the Z maximum will be TG plus TS. Then we will select the material as a Roger RO4003 from the library. We have to find out from the library. You can find any other material you want to use, and you will find it from the library. Then yes, now I'm searching from the exact material you want to use. We have found our material. We select the load, and then you click on yes, and then we are going to click on preview. There is a mistake, and we select the preview, and it seems okay. Then we select okay. Then the subtract is done. Now we are seeing that our subtract is done. Now we will design the patch. And we will repeat the same process again, and the box will pop up, and we will name the box as patch. We will put the value of x minimum as LP by minus LP by 2, and the maximum will be positive LP by 2, and we will give the y minimum as negative LP by 2. We give it the negative LP by 2. We're seeing this, and now we will give the y maximum as positive LP by 2, and the z minimum will be tg plus ts. Now we are giving the values of j minimum, and it is tg plus ts. And now for the z maximum part, the values will be given as z maximum part, the value will be given as tg plus tas plus tp. We have done this for our designing purposes. Now we will select a material as a copper. We will select the preview, and it seems okay, and so we are going to select it, and we are going to press OK. Now we are seeing that everything is looking very good. Now it is exactly the matching. So we are going to select OK. Now we will cut the yes, now the patch is done. Now we will cut the hole. Now yes, the patch is now done. Now we'll cut the hole of the antenna, which is color as pink. After knowing the dimension of the dimension of these two bath holes, we have again, now after knowing the dimension of these bath holes, we will go again to the CST software, and then we will again try to bring that box, and we will name as a sub, because we are going to cut the bath hole, and the outer radius of the bath hole will be indicated as R, because the value is given in the chat box, in the in the parameter list. Now we'll go to there, and now you're seeing the bath hole. So, and the inner radius will be like 0 0.0, and the x center is 0, and y center is I think you see, and the z minimum will be written as tg plus ts. Basically we are doing this as for designing and reproduction of this, and then we are going to select z maximum, which is tg plus ts plus tp. Then we will select the material from the library, or I think there is already, we have the material as a copper. We are going to select copper, yes, then we will preview it. Yeah, it seems okay, and seems like we have done it. And we will click on OK, and now after clicking OK, we have done our, we have subtract our, and we have cut, I think we have cut a hole in our patch antenna, a bath hole in our patch antenna. Now we are subtracting it. Now yes, and now you're seeing that our subtraction has done. Now we will subtraction have been done. Now again, because we have two holes, so again we will use the same process to cut another bath holes, and we will use the outer radius as R, and Y center will be as minus C, and the Z minimum will be like TS plus TG plus TS plus TP. Then we select them again, we will select the material and preview it, then and the Z maximum will be TG plus TS plus TP. Yes, the TP. Now we are going to select the material. Yes, the same process have been repeated. Now it's all seems okay, then we will select OK, and after selecting OK, So we we will use boolean and then subtract it down. We have another hole. Now you're seeing that the making of the base hole is done. Now we have to subtract a portion of the ground for our pin. You are seeing there is a pin and we have to make it, so we have to subtract a portion of the ground to make a hole for the pin. So now we have to again use like break it and then cylindrical form, to because it's a the pin will be a cylindrical form. In this box we will name it as a, I think, outer cover. We will name it as an, sorry for that. No, we will subtract, oh sorry, we have to first the subtract it for our ground pin. So in the box the outer radius will be 0.05 and the inner radius will be 0, x center is minus 4.8. Yes, x center will be minus 4.8 and y center is positive 4.8. Positive 4.8 and z maximum is tg. Then we will kill z maximum will be tz. Yes, everything is seems okay. Then we will put the value of z minimum as 0, as z maximum as tg. Then we will use the material as copper and held, then we'll preview it. So now you are seeing that in the ground we have successfully done a hole to make our pin, to make our hole to make our ground pin. Now we'll select OK, and now we are seeing that it has been done. Now we will select it and ground boolean subtract and then subtract it. Yes, now it is, you are saying that now it is, it's been, the hole has been done for our pin. Then again we have to cut a portion for our feed subtract. We have to cut a portion for our feed subtract, and for that we will again use a cylindrical form because it will be cylindrical, and the name will be feed sub. We will indicate as a feed sub. We will give the all the values they need, like the, we have to put first of the outer radius of the feed sub like 0.5, sorry 0.25. Then we are going to give the x center, the value of the x center, and the value of the x center will be as minus 4.8 and the y center will be positive 4.8. Then the z minimum will be the value of tg, which is 0.003, and z maximum will be also, I think the z maximum will be, yes, tz plus ts. Now we'll select the material. It's a Roger RO403. You can find it from the library. Now we're checking all the, now we're going to preview it, and it seems that we have done it. Now we are going to select OK. So now we are going to make a feed. So this our we are going to repeat this to make a feed. So this is our extended cable. So this is our, now we have to make a feeds. We have to make a feed for the patch antenna. So everything seems okay. In this way we have done the feed, we have done the outer cable. Now we are going to use, no, we are going to make a coax from the design, and we will give all the values like we have selected. And like now we are going to name as a feed. Now we are going to create the feed. So this is now we are going to feed, and we are giving the values like outer radius will be 0.25. It is basically for the feed, which will be our extended cable. Now x center will be minus 4.8 and y center will be positive 4.8. We're giving the values. Now the z minimum, for the z minimum we will put the value of 0.05, and for z maximum we are going to give the value of T0 with 0.03, and TS which is 1.575, and TP which is also 0.03, and the material we are going to use as a copper anhydride. Now we are going to preview it, and it seems very fine that we have successfully done an extended cable for our pin, for our patch antenna. Now we are going to press OK. Yes, now we are seeing that we have done a successfully draw a simulated extended cable. Now we will build a cox, and we will name it as a cox. COAX is a cox, and we are going to now what are you seeing? Now we are giving the values of the cox, and the outer radius of the values will be 0.49, and the inner radius of the cox will be as 0.25. So the x center will be, so now we are giving the value of x center as minus 4.8, and y center is positive 4.8, exactly as the same process. Now we are going to give the value of z minimum, which is 0.5, and the z maximum, I think z maximum is not, then we are going to select the vacuum, and we are going to preview it. Yes, we have done now we have successfully done to make an outer cover, and we have successfully done to make a simulated graph, to make a successful box of the graph. Now we are going to select the cylinder, and now we will draw the outer cover, and we will select cylinder and give all the values for the outer cover, and we will name it as a outer cover. We're giving the values of the outer radius will be 0.45, inner radius will be 0.49, x center will be minus 4.8, and y center will be positive 4.8. Now the values of the z minimum, we are going to give the value of the z minimum as 0.5, and the vacuum, the copper end. Now we are going to preview it. Now it seems very okay, then we are going to select OK. Now our probe design, now you are seeing that our probe design has been done. Now we will give the feed to do simulation, to select. Now for our simulation purposes, we are going to select peak face for this probe. Yes, we are going to select the peak face. Now we are selecting a face, and we have done selecting it. Now we are giving the values of the peak face we have chosen. The destination of the reference place in minus 0.5, and we're going to preview it, and now we are seeing that it seems all okay. Then we are going to select OK. So now our face has been selected for the simulation. We are seeing that our face has been selected for the simulation. simulation is doing Janta Mondol. I'm giving you all the details. So now for the simulation, we have to select the setup solver, and we will normalize the fixed impedance, and we will not use this accuracy. We will use the accuracy as -60, and we will click start. Now we are seeing that it's calculating. It will take some time. Now it's been done, so we will select the S parameter values. Now our simulation is done. Now you are seeing the S parameters. The first one you are seeing is the S11. It is almost exactly as the same we are reproducing, almost exactly as the same the paper we are reproducing. The way the graph is showing the same result. Now this is the graph of the VSWR1, the voltage standing wave ratio. It is maximum time, it's always linear. It shows always linear. So now if you want to see the, I think the E field, so we are going to select the E field, and now you are seeing the current density. Now you are seeing the current density. And if you want to animate it, so you have to just select the animate field, and it will automatically animate itself. In the case that if you want to animate itself, if you want to see the current density of this field, you can also select the E field option, H field option. It will see all the, it will reflect all the things in details. And if you also animate this, it will animate itself. Now you are seeing the density, and we animated it because we have select the animate field option. Now for the surface current, if you want to see the surface current, you just have to go to the surface current option, and you have to select the surface current f1.9. Basically, if you want to animate and if you want to a proper design, you just have to select the animation field, and you can animate all of these things as smooth as possible. Now for the far field part, now this is the far field part. And if you want to see this far field part in polar option, you just have to select the polar option, and you will select you can see the all other things as in polar form. So like if you want to change, like we are changing the values, so we are going to apply it. Like now it's been changing, it's been changed. Now we are seeing the far field diversity. Now we are going to same as the in the component part, and we have done the successful reproduction of our journal paper which we have selected, and you're seeing that all our parameters are okay and all other things are matching with the paper that we have done reproduce. So thank you so much for staying with us, and you are seeing the same values like in the original paper. The S11, this is the graph of the original paper, and this is the paper we have done reproduction is almost the same. It's almost all the same. Thank you all for watching with us, and we have successfully reproduced the paper which you have shown in the first time. Thank you for seeing all the simulation. Thank you so much.